So, we know how to find the distance between 2 points. How can we find the distance between a point and a line? Well, it depends. Look at the example where we have a point and a line. Depending on which point on the line we choose, some points on the line are very, very far away from the point. So part of the question is, what do we even mean by the distance between a point and the line? And what we mean is the shortest possible distance. Okay, how do we find the shortest possible distance? Well, the shortest possible distance is along a perpendicular line segment. So to find the distance between a point and a line, we find a line perpendicular to the line that goes through the point, and then we find the distance along that. Okay, let's look at this example and see how we can actually do this. For this example, I'm going to do it just by drawing, and then we'll see how to do it using algebra instead. So just by drawing, my given line has a slope -3/4. I could have figured that out from the graph as well, but I can see it right here in the equation. So a perpendicular line will have a slope of +4/3. So +4/3, that would be right 3 up 4. I can't do that in this picture because my point is up against the right side of the graph. So instead I'm going to notice that +4 over +3 is equal to -4 over -3, and say that I can go left 3 and down 4. So the line perpendicular to the given line through the given point is this one. The distance I want to find is the distance between my given point, which I'll call A, and the new point I just found, which I'll call B. Now A is the point x equals 4, y equals 3, that was given to me. And B is the point x equals 1, y equals -1. The distance between the point and the line is the length of segment AB, which is the difference in the x's squared plus the difference in the y's squared. Take the square root of the whole thing. Putting all of that into a calculator, we get that that's square root 25, which is 5. The distance between the point and the line is 5 units. Okay, so what did we actually do there? Well, we drew the perpendicular line, and then we found out where they intersected. We can do that exact same process using algebra. Find the equation of a perpendicular line, find where this intersects the given line, and then find the distance between the given point and the point we just found. So, first, the given line has slope -3. A perpendicular line will have a slope, change the sign to positive. Take the reciprocal of 3, that's 1/3. So the perpendicular line through this point is y minus, the given y is 1, equals 1/3. X minus -3 is the same as x plus 3. Okay, now to find where those two lines intersect, I have a system. Y equals -3x plus 12. Y minus 1 equals 1/3 times x plus 3. I know how to solve that system. I could use substitution or elimination. Since my first equation is already solved for y, I'm going to choose substitution. So Replacing y in the second equation by the expression that it's equal to, I get negative 3x plus 12 minus 1 equals 1/3 x plus 3. On the left, those parentheses aren't doing anything, so I can combine like terms. I have negative 3x plus 11. On the right, I'll distribute and have 1/3 x plus 1. Okay, now I'm going to continue solving. I want to get all the x terms on the left, so I'm going to subtract 1/3 x on both sides. All the constant terms on the right, so I'm going to subtract 11 on both sides. Negative 3 minus 1/3 is negative 10/3. 1 minus 11 is negative 10. Divide both sides by negative 10/3, or I could think of that as multiplying by negative 3/10, and I get x equals positive 3. To find y, I'm going to go back to this first equation. Y equals negative 3 times 3 plus 12. I get y also equals 3. And before I do any more work, I'm going to check that quick. 3 minus 1, does it equal 1/3 times 3 plus 3? Yeah, this is 2. This is 1/3 of 6, which is also 2. That checks out. Okay, so the distance I want is the distance between my given point, negative 3, 1, and the point I just found, 3, 3. Well, that'll be the difference in the x's, negative 3 minus 3 squared, plus the difference in the y's, 1 minus 3 squared. Take the square root of the whole thing. This is going to be the square root of 40, which is 2 times the square root of 10. So the distance between the given point and the given line is 2 times the square root of 10 units. Now, this feels like a process with a lot of steps, but really it only has 3 steps. Find the equation of the perpendicular line, put that into a system with the given line, and solve the system. And then, using the point of intersection you just found, find the distance from the given line. So instead of thinking of this as a process with a lot of tiny little steps, think of this as a process with 3 kind of big steps, and it's much easier to keep track of what we're doing.